So we're going to look at the Pythagorean identities right now. I'm going to show you where the first one comes from, and then we're going to derive the other two. Go back to the unit circle. On the unit circle, of course, I have my four quadrants, and I'm going to simply label my x and y axes. I'm going to throw an angle of rotation into quadrant 1 to make it simple. Angle of rotation here in quadrant 1. Not sure what it's going to be. I'll just throw a theta in there. And I'm going to drop that to the x-axis. Knowing that it's a unit circle, I know that my radius is 1. And I can tell you that this is x and this is y. And I know from Pythagoras that x squared plus y squared will equal 1. I also know that x is equal to the cosine of theta. We talked about that the other day. And I know that y is equal to the sine of theta. And through a quick substitution, or a simple substitution, I can replace my x with cos of theta and say cosine of theta squared plus, I'm going to replace my y with the sine of theta, so I will have the sine of theta squared, and that will equal, of course, 1. 1 squared is 1. Now, we don't actually write it like this. We write it, when we square a function, we actually write that, and I'm going to reverse the order here. It's going to be sine first, and so rather than writing it in parentheses, squaring it, I write it as the sine squared of theta plus the cos squared of theta equals 1. And that is my first and my main Pythagorean identity. Okay, so this is, again, the main Pythagorean identity. Yet another thing you have to memorize. You could derive it if you wanted to, if you needed to know it, but it's probably easier just to memorize the identity. What I want to do now is show you two different Pythagorean identities that are derived from this main sine squared theta plus cos squared theta equals 1. So what I'm going to do is I'm going to start with that, and I'm actually going to take this Pythagorean identity and divide everything through by the sine squared of theta. So I'm going to divide all three terms by the sine squared of theta. And then I'm going to simplify this or convert this. So what I can tell you is that sine squared divided by itself is going to, of course, give me 1. Now, I know that cosine divided by sine is cotangent, because I know that sine of theta over cos of theta is tangent. So the reciprocal cosine theta divided by sine theta is going to be the cotangent of theta. Square the functions, and I will end up with the cotangent squared of theta. I also know that 1 over sine is equal to cosecant, because that's the reciprocal function. And so I can replace 1 over sine squared with the cosecant squared of theta. So this is Pythagorean identity number 2. Okay, I'm back to my main identity again. This time I'm going to divide every term through by cosine squared theta to see what happens. And as I manipulate each of these terms, I will end up with another new identity. So, once again, sine squared over cosine squared. Knowing that sine divided by cosine is tangent, I can tell you sine squared divided by cosine squared will be tangent squared theta. Plus cosine squared divided by itself will be 1. And then, of course, 1 divided by cosine, or 1 over cosine. Reciprocal to cosine is secant, so 1 over cosine squared will actually be secant squared of theta. And this is Pythagorean identity number 3. So what I want to do is I want to write each of those so that you can kind of see the pattern. So what I have here are the Pythagorean trig identities. The first one, of course, is the sine squared theta plus cos squared theta equals 1. The second one, and I'm going to write these in a little bit of different order just to make it easier to memorize them. Second one will be tangent squared theta plus 1 equals secant squared theta. And then number 3 will be the cotangent squared theta plus 1 equals cosecant squared theta. What I want you to realize is that the second one and the third one are very similar in that one of them is a tangent squared plus 1, and the third one, or the other one, is the cotangent squared plus 1. So these are very similar in that this is the co-function of the first, and that holds true over here on the right side also. So tangent squared plus 1 equals secant squared. If I just take the co-functions of those, cotangent squared plus 1 will equal cosecant squared. So in a way, if you can memorize number 2, you just take the co-functions and you've got number 3. You can also go back to the original and just remember how we got these two. One of them was found by dividing everything through by sine squared. The other one by dividing everything through by cosine squared. And if you can manipulate those in your head, you know, again, sine squared over cosine squared, we know that's tangent. That's that. Cosine squared divided by itself. 1 over cosine squared, secant squared. So you can derive them on the fly if you need to, or you can simply memorize the 3 Pythagorean identities. Whichever way you choose to do it, you need to realize that you are responsible for these 3 Pythagorean identities. Nobody's going to give them to you on a test. They're not on a reference sheet. So you need to have them memorized. And again, sooner rather than later. Just like you need to know the reciprocal functions. You need to know the quotient identities. You need to know your special angle ratios. So all of these, again, continue to build. All right. So when you come to class, we will look at how are we going to use these Pythagorean identities.